Hello, I'm John Willis. I work at Red Hat, also known as Botchgaloop on Twitter. Today we're doing a presentation called Security Differently, or sometimes called what I call the blurred and broken lines of defense. So most of you probably know me. I've been around for quite a while. I'm pretty easy to find. In short, I've written about 12 books over the last 40 years and been in about 11 startups somewhat. Probably most notable book is the DevOps Handbook with Gene Kim, Patrick DeBar, and Jez Humble. I also did Beyond the Phoenix Project with Gene Kim. Worked on some interesting working paper, which became reference guides, DevOps Automated Governance and Automated Cloud Governance. I'll be covering those two a little bit in this presentation. And I help, in an advisorship for some of the Unicorn Project work with Gene books. A wonderful book. And then a lot of startups. Sold a company to Dell, sold a company to Docker, was an early in on cloud at Canonical. This is pre-open stack. And I'm involved in the DevOps movement. Was one of the early advisors, core organizers of the original DevOps days, and then also DevOps Enterprise Summit. And today I work at Red Hat. One last thing, I've always been pretty much a geek on Edward Deming, so I started a podcast recently, so it's sort of my passion, called Profound. If you're interested or you want to talk about Deming or you know something about Deming and would like to discuss, just reach out to me. Love to hear from you, or maybe even be on the podcast. So one of the things I did when I started thinking about this presentation for this year is ask this question. I do this a lot when I'm starting out in the beginning of the year of writing a themed presentation that year, and this one being Security Differently in 2021. I was asking this question to myself: what would DevSecOps look like if DevOps never existed? And so if we think about DevSecOps, it's been, the glass is definitely half full, right? In other words, we've added lots of security onto our pipelines. We've built some really awesome DevSecOps reference architectures, a lot of automation that didn't exist, bolted onto our sort of DevOps things, our pipelines and whatnot. But in some ways, like the picture to the left there, have we tried to force a square peg into a round hole? And a lot of good things are making it through. But the question I guess I'm asking is, what if DevOps never existed? What would DevSecOps look like? In other words, were we forced into a model or some bias around DevOps? Again, not criticizing the good work we've done, but just questioning how would we have done things a little bit differently had we just started with the notion of DevSecOps and not tried to sort of bolt on security to the DevOps model. And one of a couple of examples, and I just wanted to pick one, which is this notion of the 3 lines of defense. So a lot of times when I go into a large shop and I talk to people and they show me their sort of DevSecOps reference architecture, and I'm like, yeah, that's really cool, that's awesome, and they've done all the sort of good things that you need to do. They're doing, they basically got good hygiene on terms of delivery, small batch, all the sort of good DevOps principles. But then they're also doing their SAST, their DAST, and all that in the pipeline, and again, all the things that you'd find in probably a good hygiene DevSecOps reference architecture. But then in the same breath, they'll talk about how we follow the 3 lines of defense model. And there's different sort of versions of this, but one of them by the Institute of Internal Auditors. And that's where, by design, the organization is encouraged to actually create these walls, right? You have sort of the third line, which is internal audit, and then you have second line, which would be sort of risk owners, and then you have first line as the actual control, the control people who actually implement the controls. And this design is predicated on basically silos, firewalls, if you will, sort of firewalling the different groups or the silos on purpose. Like, in other words, the second group will catch what the first group, and the third group will catch what the second group doesn't catch. So this is an anti-pattern, if I, in terms of like, that's the sort of square peg in the round hole, in my opinion. And if we think about, the original intent of DevOps, in fact, the original caricature, this is Andrew Clay Schaefer, who I work for over at Red Hat, and it's a dear friend of mine for many years, one of also the sort of founders of the DevOps movement. Early in 2009, the original Velocity, where we started talking about O'Reilly's Velocity Conference, we talked about some of these ideas, where John Allspar that gave his famous 10 deploys a day of Flickr. Andrew, at the same day, was giving a presentation called Agile Infrastructure. And in his presentation, he showed this, this now famous caricature of the wall of confusion, where dev and ops had these different goals, and there was always this sort of wall and non-collaboration. And then also, I think what we find, if we go back to the Conways Law, this adage stating that organizational design systems mirror their communication structure. So what you sort of put in, so if you have that wall between dev and ops, and we've successfully smashed down that wall in the DevOps conversation over the year, but if you don't, your organizational design of how you deliver your software, how you communicate, all those things become a mirror of that communication, or that sort of wall in a place. So what I would argue then is the three lines of defense is a great example of an anti-pattern to what we possibly should have had with DevSecOps, but we feel like it's a normal practice, but it really is these two walls of confusion where we're sort of by design not enabling collaboration, and in a sense creating some of that sort of square peg that's not getting through, where possibly if you didn't have this particular sort of mandate or organizational structure in place, you'd have better collaboration between audit. I mean, that's one of the big problems we find today is how do you get audit and the service delivery teams to talk? How do you get the risk control to have a conversation about regulatory controls? And a lot of that, we're not seeing a lot of positive activity in large organizations. And then there's also the Larman's Law of organizational behavior. And I think, we won't go through all these, but I sort of, I love number 2, the second law, if you will, which is any change initiative will be reduced to findings of overloading the new terminology to mean basically the same as status quo. In other words, that is part of the problem, right? Even when you start to try to collaborate, certainly if you have the walls and you have this collaboration between internal risk or risk control owners and people, service delivery teams, that they're going to sort of, even if you sort of push them in the same room to have a conversation, if they're not freely communicating, they're basically going to oh yeah, we do that. Okay, good. And they're going to agree on sort of overloaded terminology or sort of walk out of the room really not communicating, but sort of agreeing. So where this puts us then is all these sort of issues are true here, but also when we start thinking about the complexity of a post-cloud native world or post-cloud native development, what we find is these opportunities for higher risk become more accentuated, more bigger gaps. So there are these sort of 3 principles that are universally true, whether you're in sort of a post-cloud native world. I use this phrase, it's probably a terrible phrase, post-cloud native modernization. I mean, the things that are sort of happening, your sort of microservices, your cloud native development, your containerization, your clustering, your even your sort of functions, as you will. These things, regardless of that, you should be, thinking about how do you prove that we're safe, to how do we demonstrate that we're secure, and how do we do both. But in the post-cloud native world, it even gets worse, right? Because the complexity of like service mesh and just we can go on and on. And the question is that if we're asking how do we prove that we're safe, how do we do that today in most organizations? Pre or post cloud native, which is we typically use ServiceNow or change records, and we document sort of human conversation of, yes, I'm going to do this, but I prepare for that. And then somebody asks a question, well, what happens if this? And, before you go to production, I'd like to see this. And it's all this subjective conversation. And then how do you demonstrate? And the truth is, you really don't, right? Except it's an audit. So maybe once a year you have an audit, 30 or 40 days, high toil, low efficacy. But the question I'm trying to raise here is, if we're doing security differently, maybe proving how we're safe should be more objective or explicit. And how do you demonstrate it should be sort of immutable and instantaneously. So in order to be able to do both. And so what needs to happen security differently, 2021, move from implicit security to explicit proof-based, right? And in this case, not sort of implied in a ServiceNow record, but explicit through automation. Or more specifically, let's change the subjective nature of how we do things to objective and verifiable. Again, instead of a human, let's go ahead and make it electronically, maybe digital signatures in the subjective things we can show during the automation without any human intervention, and verifiable. And we'll show some examples of that. So what I've done is I said, okay, there's this notion then, I guess, what I would say is called modern governance. And what is the transition? And if we look at the post-cloud native world, right? If we look at security, we talk about DevSecOps. One of the things that's always sort of bothered me about the DevSecOps conversation is once you start describing, sort of the culture and behavior patterns that we inherit from DevOps, right? Very good stuff. But then all of a sudden, now you look at all the sort of security things. It's a pretty wide horizontal spread. And so when we start, I would always talk about DevSecOps, and somebody would come up to me, John, well, what about this? So what about that? And I felt that it was hard to use that one word for the large breadth that we have of sort of security. So as I started thinking more about this sort of modern and this post-cloud native world, I mean, what are the really important things in this post-cloud native world, right? And really, to me, it boils down to three things that I can sort of look at and say, well, this is modern governance, and this is what we need to be thinking from subjective to objective and verifiable, okay? And there's a lot of stuff. So risk is one of them, defense, and trust. So if we look at risk, we move from subjective change management to electronic, digitally signed attestations and control in the pipeline, automated, no human intervention, and then ultimately move into verifiable, which could be something like continuous verification or chaos engineering, or security chaos engineering. So where we're constantly verifying the things that we set during the delivery and the attestation. Right, maybe this port should never be open as part of this sort of configuration definition, but let's just test that. Or maybe this vulnerability should never be in a container image in production. Well, let's basically start a container image and see what happens with that vulnerability. On the defense side, we look at moving from subjective detect and respond to intelligence and data lakes, where people are constantly taking all the information and creating sort of the metadata to normalize your information, getting really intent about sort of decorating information from multiple clouds, multiple passes, just anywhere. And we move into something that Shannon Leitz, who has been a great mentor of mine, she was over at It, she calls adversary analysis. This is your verifiable, which is where you're just constantly using automation to attack the environment from the outside in. And then finally, in a trust, in this modern governance, we move from perimeter-based to zero-trust architectures, right, which sort of everybody's kind of gotten that memo. But even zero-trust architectures are not good enough because, if you look at a lot of these major breaches we've had, is they're usually an account takeover or a server-side request forgery. So even in a zero-trust environment, if you can sort of impersonate or fake forgery your identity, especially in cloud environments where there are sort of a lot of shared environment authorizations, like take, for example, metadata server, once you compromise that. So we move from verifiable into more of a distributed trust model where we have these trust circles and clusters. And I'll talk a little bit about that a little bit. So if we look at risk differently, what we're trying to do is reduce audit toil, increase audit efficiency, right? Or efficacy, sorry. And, and we're using automated, objective, immutable evidence, right? Talked about digitally signed evidence. We're using continuous audit and verification, sort of security chaos engineering. Back in 2019, I've given presentations at a bunch of sort of industry leaders. We created this DevOps automated reference architecture where we showed how you could create these different stages and create gating and attestations, these evidence through digital signatures. And we over the years we've added in the original guide we had like 75 attestations. This would be your evidence points during the pipeline. But as you can see, we've expanded this, and just for example, you can look at things like unit test coverage, maybe a percentage, change size, cyclomatic complexity, pull request branching strategy, clean dependencies, and then moving on to this sort of build stage. All the things that would sort of be in the build stage, like even a SAS scan for something like JFrog, X-ray. And then the package stage, right? Of course, artifact is a great example here. We could do artifact version, package meta, and again, container scanning with something like JFrog X-ray, and then on to the pre-pod, and on and on. Also, one of the things that we found was that after we built in that reference architecture, the sort of staging, attestations, and the ability to enumerate the different control points and evidence, it made sense to actually start thinking about, could that be driven by some type of DSL, a risk is code or sort of policy DSL, where the sort of intent could be a collaboration between, something like a third line of defense, again, breaking down those walls, second line and first line, all collaborating to create sort of a YAML file. And you might laugh, but there's a couple of banks right now that are actually doing this, where their collaboration is this artifact. And like that SolarWinds Law, it's less likely to create overloaded terminology if the agreement is you have to create a DSL artifact, as opposed to agreement on some verbiage that goes into a change record. Like I said, we started down in 2019, wrote this reference architecture. We're actually writing a second version now, which is should be out later this summer. It's a lot of fun. In this version, the first version was just a rote, dry, kind of boring reference architecture. But this time we're doing sort of stealing a page from the Phoenix project, where we're actually creating a company called Investment Unlimited, and we're talking about how they failed an audit, and it's a lot of fun. The other thing I wanted to mention is I had this opportunity earlier this year to be invited in to give a presentation to some of the SolarWinds executives. So we've all heard about the SolarWinds breach, and I was asked by a friend who knew my passion for automated governance, the paper that we're working on, the follow-on work. And so I gave a presentation, and what I was able to do is I went out and I looked at some of the really good, sort of explanations of the actual kill chain that actually infiltrated the SolarWinds, not what happened to everybody else with the SolarWinds software. And so CrowdStrike and MITRE actually had probably the two best write-ups. And one of the things I wanted to do is show, not like it was, the perfect example, but show how a lot of the things that was going on there for a couple of years could have actually been highlighted through this sort of approach that I'm talking about security differently, specifically automated governance. And here's the MITRE paper. So the CrowdStrike is very specific, that blog article. This is an overall great read about what MITRE is doing and the whole sort of process. So both are a good combination. So what I did is I went in and I took the things that were described in the MITRE attack tactics and just played what if with an automated governance structure, which is, again, won't go through all these. You can read these. The slides will be available. But like, for example, I think one that really stood out to me was the code signing. One of the things in the CrowdStrike was there was constantly hash mismatches. If you know how the breach occurred, basically they were able to sit in there, wait, and compromise MS build so that they could add their code into the delivery, and there was just all this evidence of code mismatches, signing mismatch or hash mismatches, which could have been caught with like a cryptographic hash code signing attestation or gate. There was also examples of log masquerading, so an immutable log structure could have been used. Image scanning. There was just all sorts of things that these could have been, really highly raised red flags or gates in the development, or at least instantaneous verification from a continuous compliance or automated governance structure. And so, we talk about sort of modern risk solutions. We definitely automated governance. In Red Hat, I've been working on some tools called Plygos, which is sort of software factory. Certainly, I have the JFrog suite of products. In the original paper, one of the things that we did, which was we focused in on Grapheus as this attestation repository store, but there's been some real good developments in something called SigStore, which is based on a Merkle tree. Certainly, Red Hat has some interesting tools in terms of compliance operator, advanced cluster management. Here again, I'm a big fan. That's why I speak almost every year for the 4 or 5 years at SwampUp. The JFrog, Artifactory, X-Ray, all their tools, and then we talked about the continuous verification. Also, if you haven't had any look into this software bill of materials, these are some of the interesting industry things that are going on. This is a fascinating subject. I'm actually going to write a whole blog article about what's happening in the transition here. I think it's a very important piece. And if we talk about defense, that's second in that sort of 3 points that I mentioned earlier, with risk, defense, and trust. If we look at the defense differently, so in defense, basically what we want to do here is reduce defense toil, increase, same idea, reduce the toil, increase the efficacy, start looking at a more unified approach to SIM and SOAR, all this sort of information that's coming in from sort of everywhere, but certainly multi-clouds, the passes, and then start looking at sort of creating a common meta to create the intelligent, like a cyber data lakes, getting more advanced in deception technology. And I talked a lot about what Shannon Leach has been working on, is adversary analysis, a very interesting topic. This was another working paper that I worked on with a group of people, where we focused on cloud, became automated cloud governance. This is like the earlier paper. There's all Creative Commons and available. And this is some of the organizations that worked on the original, and we're sort of halfway through the second paper. But FedEx, Goldman Sachs, Cigna, just on and on. So a lot of large organizations. And basically, again, trying to sort of create this commonality between all the data that comes in from all these different cloud providers to sort of aggregate for our GRC purposes. And we actually wound up calling this the Cloud Security Notification Framework. ONUG is the sponsoring organization. They've just done a large a conference here in May, and we've really sort of, you can find a lot of information about what we talked about. But basically, this idea of creating this decorator for all this SIM and SOAR data, where we can get common from different cloud providers, but then really importantly, allow to aggregate the common meta. The problem being like one event from AWS or another event from Google or Azure might have the same meaning, but the context and the structure are going to be different. And so how do you normalize that? But even sort of harder is, how do you get the common meta, like the department, the account, the resource name? These are all different. So we've done some tremendously good work there. And so to wind that down, the solutions are these intelligent cyber data lakes. Again, I would definitely advise you to, if this is of interest, ONUG. We just had our spring conference, and we talked about the Cloud Security Notification Framework, MITRE attack framework. Brilliant stuff. Look into SCAP, Open SCAP, cyber ranges, another interesting topic. And then for the adversary analysis stuff, like this, there really are no products, but follow Shannon Leach's work. She's spoken about this at numerous conferences. And then finally, in the trust differently, so the third leg, We'll go quickly through this because there's a lot here. Any of these should be their own presentation. I'm just giving you sort of a survey of this sort of security differently. We talked about zero trust architectures, automated control-based assessments, some of the stuff that is used for FedRAMP documentation. There's some great tools out there. I'll point that out. Distributed secrets management. Of course, Vault is a good tool, but even I think the world is even going to get a little more complicated in Vault, right? And we'll show you some of the things. And these distributed trust. So one of the main points I'm trying to make about trust was we need to move from a north-south sort of model. If you think about like a lot of authentication and how we do this, very much still, even in the worlds where we have complex sort of container clusters, service mesh infrastructures, we're still using, sort of mentally the north-south. We need to get to east-west like transactions for security, or trusted security pods. Very interesting stuff. I'll show you some of the technologies. So certainly for zero trust, the NIST 800-207. Spiffy is a really interesting tool for this, what I would call east-west trust. And then this SigStar, which is a tool that has been developed out of Red Hat, that was originally based on Google's Trillion, which was originally for certificate transparency, but it actually has audit capability. And what SigStar is really more of a simplified tool to abstract the Trillion API. So SigStar is actually a collaboration effort between Red Hat and Google, but it has these possibilities to expand the whole notion of trust electronically and distributed in what I would call what I call east-west transactional trust. Anyway, so I know I went through some of this pretty quick, but the intent was to be more of a survey view of this whole what I call security differently. Thank you. I'm John Willis. I can be reached at jwillis@redhat.com or Bachagalup on Twitter.